Hi, this is Mr. Nazarian. Our lesson objective today: I can solve word problems involving addition and subtraction of fractions. 5th grade standard, numbers and fractions, A2. Madeline walked 2 4/8 miles in the morning and another 2 1/3 miles in the afternoon. What was the total distance she walked? So just like any time that we're working with word problems, we want to read through it, look at the information that we're given, but most importantly, we want to start with what? That's right, we want to look at what is the question, so we know what we need to find the answer for. So now that I read this and it says, what is the total distance? That is a big cue for me to tell me that, hey, I'm not trying to find the difference between these. I'm not going to be subtracting, right? I want to know what the total distance is of the morning and the afternoon, these two pieces of information that we're given here. I need to put them together. So what mathematical operation am I going to use? What kind of math am I going to be doing? What am I going to do with these two mixed numbers? That's right. I'm going to be adding them. So I'm going to take these two mixed numbers and I'm going to add them together. So now that we've read through it, we know what the question is, we know what we're trying to solve, we can apply the skills that we've learned of adding mixed numbers. So I'm going to use one strategy that we've worked on. Of course, it's not the only strategy, but I'm just going to pick one to work with, and the one I'm going to use is I'm going to separate these mixed numbers. Of course, a mixed number is made of a whole number and a fraction. So I'm going to take the fractional parts of the mixed number, and I'm just going to work with those right now. So I'm going to kind of pull them apart. So I have 4/8 plus 1/3, and of course we can't add eighths and thirds. We need to find a common denominator for those fractions. So we need to find a common multiple of 8 and 3. What would a common multiple of 8 and 3 be? What would the lowest common multiple, I should say, be of 8 and 3? That's right, 24. So that means instead of adding 4/8 and 1/3, I'm going to find an equivalent fraction of 4/8 with 24 in the denominator, and equivalent fraction of 1/3 with 24 in the denominator. So then we're adding 24ths. So what would an equivalent fraction of 4/8 be with 24 in the denominator? So how many 24ths equals 4/8? Okay, so you of course need to do the same thing to the numerator as the denominator. So what have we done to the denominator? The 8 to change it to a 24, we're going to multiply by 3. So, because 8 times 3 equals 24, and that means we have to do the same to the numerator. So 4 times 3 equals 12. So 12 24ths. What would an equivalent fraction of 1/3 be in 24ths? How many 24ths equals 1/3? Okay, same thing here. We need to figure out, what did I do to this 3 to make a 24? Well, 3 times 8 I know is 24. It means I have to do the same thing to the top. 1 times 8 equals 8. So the fractional part here, 12 24ths plus 8 24ths equals what? It equals 20 24ths, right? Okay, and I'm not going to worry about reducing right now. So, of course, though, we're not just multiplying the fractions, we're multiplying mixed numbers, so we need to remember the whole number part too. So the whole numbers of these two mixed numbers are 2 and 2, so I'm going to add 2 plus 2, and of course that is going to give me 4. And all I need to do is take this fractional part, now we're putting them together, the fractions and the whole numbers. Now we have our mixed number. 4 and 20 24ths would be the total of how many miles Madeline walked. So I'm going to actually also label that, because that's important, because we could be talking about anything, right? So in this case, that 4 and 20 24ths represents how many miles she walked. Okay. Next one is a large box of nails weighed 3 4/10 ounces. A small box of nails weighed 2 1/2 ounces. What is the difference in weight between the two boxes? I'm going to leave this one up to you. So go ahead and solve for this problem. What is the difference in weight between the two boxes? Okay, so I'm going to move right through this. So of course, again, first most important thing is we are going to see what's the question, and the question is, what is the difference in weight between the two boxes. So difference gives me a huge clue as what kind of mathematical operation I'm going to be doing here. Difference is the answer to a subtraction problem. So that means I'm going to be subtracting the weight of the small box from the weight of the large box to give me the difference between the two, to see how much more that large box weighs. So it is going to look something like this. 3 4/10 minus 2 1/2. Of course, we've used the strategy of course, you can change this to an improper fraction first. So we could change them to improper fractions, give them a common denominator, subtract them, and then change them back to a mixed number. And for a lot of people, that's the best strategy. I'm going to use that same similar strategy to what we used for the addition one. So I'm pulling apart the fractional parts and just working with that first. So 4/10 minus 1/2. Again, I can't subtract tens and halves. I have to make them a common denominator. So common multiple of 10 and 2 is 10. 10 is a multiple of 10 and it's a multiple of 2. So 4/10, it's already in tenths, right? So I'm just going to leave that. So 4/10 is equivalent to 4/10, obviously. And then 1/2, 2 times 5 equals 10. So 1 times 5 is going to give me 5. So now we have a problem, right? And as we've worked through this, people that have used this strategy have run into this problem, right? Where we go, okay, well, we'll just pull apart the fractions, and then we'll subtract that, and then we'll subtract the whole numbers, and that's great. But a lot of times we end up having this, I wouldn't say a problem, but I guess you could say it's a problem. It's an obstacle. It's a challenge for us, because we can't subtract 5/10 from 4/10, right? And it's too much. So what we need to do is, because this total mixed number here, 3 4/10, is more than 2 1/2, but it's just the fractional parts by themselves where this first number is smaller, right? So what we need to do is regroup. So this 3 is the same thing. It's the same value as 2 plus 1, right? 2 and 1 is the same as 3, right? And that 1 whole is the same as 10/10, right? So since we're working with tenths here, we're just going to make this 1 whole 10/10 because it's the same thing, right? 10/10 is the same as 1 whole. Then I'm just going to grab this 10/10 and I'm going to regroup or borrow and put it together with this 4/10. So now I have 10/10 and 4/10, which is equal to what? What's 10/10 and 4/10 equal to? It's equal to 14/10, right? So that means I'm going to take 14/10 is what I have now, and then I'm going to subtract the 5/10, and that's going to give me 9/10, right? So now that I'm done with the fractional part here, this 9/10, now I just need to subtract the whole numbers. Well, this is no longer a 3, right? Because I regrouped, I borrowed. So remember, it was, instead of a 3, it was a 2 and a 1, and then I took that 1, broke it into tenths, right? And I gave it over here to the fractional part. So now I only have this 2 left here. So now it's 2 minus 2, which of course is 0. So I have 0 for the whole numbers, and I have 9/10 for the fractions. So that's my final answer, 9/10. And he was, oh, and that's right, it will be in ounces, right? Okay, and OZ is another way of saying ounces. Okay, so that's what we're going to work on tomorrow. See you then. Bye.